I'll come back to questions afterwards. All right, please copy this question down. You wrote the steps down just a moment ago. In order to simplify a complex fraction, what's the first step? You should all of you should have it on your paper. Diavion.
Write the expression in the numerator as a single fraction.
Thank you. So the expression in the numerator is 1. How can we write that as a fraction? Do you know?
1/1.
1 over 1. So we'll take the expression in the numerator, write it as a single fraction. That's step number 1. So the numerator, we'll turn that into 1 over 1. Step number 1 is to write the numerator as a single fraction. Step number 2 is to write the denominator as a single fraction. So in order to write the denominator as a single fraction, in the denominator we have 1 plus x over y. This is essentially 1 over 1 plus x over y. What do we need to add fractions? Common denominator. Do you know how we could achieve a common denominator just down here? Exactly. Multiply top and bottom by y. Does everyone follow? Do you have me on? Just this fraction here. The fraction on the left, numerator and denominator by y. No, no. So now we're just working in the denominator. So we're going to multiply this by y over y. This becomes y over y, 1y over 1y plus x over y. Before we continue, does anyone have any questions about what's going on in the denominator? So we still haven't wrote it as a single fraction. So to write that as a single fraction, the numerator is still 1 over 1. The denominator, well, how could we express the denominator as a single fraction? What is y over y plus x over y? Brianna, y plus x over y. So step number 2 was to rewrite the numerator as a single fraction. We did that. Step number 2 was to rewrite the denominator as a single fraction. We did that. So we did step 1 and 2. Any questions about the first 2 steps? All right. Once you have a single fraction on top, a single fraction on bottom, I'm going to do this the long way, but the more you do this, you'll start to find shortcuts. I don't want to teach you shortcuts because then you might get confused about what's going on. So the long way would just simply to be, once we have a single fraction in the numerator, a single fraction in the denominator, this is expressed vertically. I'm going to express it horizontally. So I'm going to put 1 over 1 divided by y plus x over y. So all I did, I took this expression, which is expressed horizontally, numerator, denominator, and I rewrote it horizontally. They mean the same thing. 1 over 1 divided by y plus x over y. The reason why I'm writing it horizontally, again, after a couple of these, you could just start to skip steps. But the reason why I'm writing it out horizontally, so you could see the keep, change, flip in action. So once you have a single fraction here, a single fraction there, we could do keep, change, flip. And you all are familiar with keep, change, flip. When you divide by a fraction, it's the same as multiplying by the reciprocal. So we'll keep the red one as 1 over 1. We'll change the operation from division to multiplication, and we'll flip the blue fraction to y over y plus x. So we have 1 over 1 times y over y plus x. So now that we have 2 fractions being multiplied, 1 times y is just y. 1 times y plus x is y plus x. This is our simplified complex fraction. We began with the complex fraction over here. This is what we began with, complex fraction, and we simplified it to a simple fraction. That was example number 1. Does anyone have any questions about example number 1? Let's move on to example number 2. So please copy this example into your notebooks. This is the last one. Once we're done, we are done. And you could work on this assignment for the rest of the period. If you want to start 8-6 today, we could do that as well.
Do we skip step 1 when it looks like that?
What does step 1 say?
Write the expression in the numerator as a single fraction.
Is that a single fraction?
So how do we?
Excellent question. Excellent question. So step number 1 is to write the expression in the numerator as a single fraction. So we have 2 fractions in the numerator, and we're being asked to add 2 fractions. When we add 2 fractions, what do we need? Common denominator. Do you know how we can achieve a common denominator in the numerator? We're just looking up here. How can we achieve a common denominator for these 2 fractions up here? Diavion.
Multiply the first one by 3 and the second one by 2.
That wouldn't achieve it.
Oh wait, denominator, not numerator.
We need common denominator.
Oh, okay, then multiply the first one by y and the second one by x.
Exactly. So we're going to multiply this first one by y over y. This is going to be 2y over xy. We're going to multiply this fraction over here by x over x. This is going to be 3x over xy. Let's just stay in the numerator for now. We'll go down to the denominator in a second. Now that we have a common denominator, we just add the numerators. So the numerator is just going to be 2y plus 3x over xy. Does anyone have any questions about the numerator? Step number 1 is to write the numerator as a single fraction. We've achieved that goal. The numerator is a single fraction. Good? Let's move down to the denominator. So we have 2 fractions. We need to add these 2 to make a single one. We need a common denominator. What do we need to multiply each fraction by in order to achieve that goal? Multiply this one by y over y. Multiply this one by x over x. We get negative 5y over xy plus 7x over xy. Now that they have the same denominator, we could add the numerators, which is negative 5y plus 7x over xy. Step number 2 is to write the denominator as a single fraction. So now that we have a single fraction on top, a single fraction on bottom, you could do keep, change, flip right now if you're comfortable doing it that way. I'm just going to write it horizontal, so if you want to see the process, you could see it. But from this step, if you want, you could go ahead and do keep, change, flip. Just don't make any mistakes. So I'm going to write it out horizontally. 2y plus 3x over xy divided by negative 5y plus 7x over xy. Again, this step is optional. So we'll do keep, change, flip. We'll keep the red one the way it is, 2y plus 3x over xy. We'll change the operation from division to multiplication, and we'll flip the fraction in blue to xy over negative 5y plus 7x. Any questions about the keep, change, flip component? All right, so now We know that if we multiply the top, it's going to be xy. It's going to be 2y plus 3x times xy. And the denominator is just going to be xy times negative 5y plus 7x. Now we have a single fraction. What are your thoughts? What do you think we could do here now that we have a single fraction? Tessa?
Cancel the 2xy sign.
Exactly. We have common factors on the numerator and denominator. We could cancel those out. Good observation. So this gets canceled out, and that gets canceled out. So the only thing left is 2y plus 3x over negative 5y plus 7x. One simple fraction. We started with a complex fraction. This is what we began with, a complex fraction, and we simplified it to a simple fraction. Any questions? That is the end of the lesson.